Okay, let's start by building our own phantom that needs to be we need to approximate somehow the same phantom with different discretizations. So we should have the idea of our own phantom defined in the square So we think that the geometric domain of our phantom is the same all the time, regardless of how finely we pixelize it. And let's put in a few rectangles. So anyway, this is a function, so the result equals, let's call it, I don't know, square phantom, and as an argument, let's take what should we call it? M. So that it will be an M by M image we get. So here, let's put as an argument M, the final image will have size M times M and returns pixel image which is a discrete model of a non-negative X-ray. So the idea is that in most of the area it has value 0, and then we'll have a couple of rectangles where it has a different value than 0. All the time some mistakes. But anyway, let's initialize as 0. So the result will be zeros of size M by M. Let's save it. Square phantom, and here. Let's first just make a try. Or actually we need to construct evaluation points. Construct M by M evaluation points inside the square, inside the unit square. So let's see. These should be the center points of pixels. And there are M pixels. The width of one pixel will be, so pixel width will be 1 over M, I think. And then we need the X and Y coordinates of the center points of pixels. So let me put a make a temporary vector where we have pixel width divided by 2. That would be the, let's say, x coordinate of the center of the first pixel. Then we need 0 to m minus 1 times pixel width. What do you think? Should this be the, let's say, x coordinates of the center points of our pixels? I think there are m pixels, so we need m numbers. That's what there is. And it starts with half a pixel width, and then it goes by steps of 1 pixel width until it's almost 1. Then we need, of course, x and y coordinates. I will use the MATLAB command meshgrid, one of my favorite commands. Meshgrid temp. Now I fear I have lost some of you. Let's just quickly see how this thing looks like. If we just take m equals, let's say, 4, and let's run these. Like this, and see what happens. Well, temp is now these numbers, so going almost to 1. And what is x and y? If you haven't used meshgrid before, here you see how it works. For the x coordinate, it gives a matrix of the size. You see, it's a 4 by 4 matrix, as our image has the size 4 by 4. And this just gives the x coordinate of the center of each pixel. And the y similarly varies vertically and is constant horizontally. So these are the x and y coordinates in our image. Well, the y coordinates, they are kind of getting bigger when you go down, which is maybe a bit strange. That's a MATLAB convention anyway. So now if we want to build a rectangle, I would go like this. I would say index, the first index would be when, let's say, x is bigger than 1/4 and x is smaller than 1/2 and y is bigger than 1/4 and y is smaller than half. For example, like this. And then our result, which so far consists only zeros. Now we put here, let's say, value 1. And let's now take a look how our phantom looks like. Namely, let's make a new file. Take a look at the phantom. Let's say m equals 32, and then our image is square phantom m, and then let's take a look how it looks like. And let's put actually, come on, what's going on? Ah, okay, yes, so square phantom plot. What is this? This is the wrong place. Here. Okay. Let's see. Oh, and I want this axis equal. Let's put there axis equal so that our square domain will be square and not a rectangle. Okay, so there is our rectangle. Both coordinates, the values 1 are where both x coordinates and y coordinates are between 1/4 and half. And y coordinates are going from top down, which is a bit strange, but that's the MATLAB convention. We could actually change that because it looks so weird. We could here we could flip up and down y so that we get the coordinates going from down to up as is usual for y coordinates. And also here I think maybe let's put here from 0 to with step of 1/4 up to 1 and with bigger font so that you can see, and both x and y. Oh, sorry. Okay, so here we have the 32 by 32 image where we put this one square in it. And so you see this is, oh, let's have actually a bigger font size. So this is the 32 by 32 version of our phantom. And now we can have the phantom in different sizes if we want it to be bigger. Now we get a bigger resolution, but the phantom is the same.
For
yep.
clarity, should we like also flip that y-axis not numbering? No. I mean,
Yeah, I see what you mean, but this is something really tedious now to do with MATLAB, so we will not do that. But the idea here is because anyway, this is kind of correct because this is the pixel numbering. These are not the x and y coordinates, which should range between 0 and 1, both. So we should think that this is the unit square where x and y coordinates are ranging from 0 to 1. And MATLAB is showing us the pixel dimensions of this pixel image, which is a different thing. So my answer, I guess, is that let's just think that this is a good thing. Okay, so I think it's time for the break. Let's add a couple of more rectangles, 15 past.